Hi there! In the previous video you have seen how to visualize data using a box plot. In this video you will learn another frequently used graphical summary, namely the histogram. A histogram is a convenient way to visualize a large dataset. Let's see how we can construct one for a dataset about the Old Faithful geyser in Yellowstone National Park. This is a geyser that erupts a few times a day, and each eruption lasts for a few minutes. For the first few eruptions, the duration of each eruption, measured in seconds, is shown here. We have 272 observations in total. First off, we divide the data range into disjoint intervals called bins. Usually one will take these to be of equal width, and we can, for instance, take the intervals 80 to 100, 100 to 120, and so on. Each time not including the left endpoint, but including the right endpoint. Then we count the number of data points in each interval, also called the frequency. There are 2 observations in the first bin, 53 in the second bin, and so on. We then draw rectangles with each chosen bin as its base and the frequency as the height. Notice the leftmost rectangle, which has the interval from 80 to 100 as its base and which has height just 2. The second rectangle has the interval from 100 to 120 as its base and it has height 53, and so on. This histogram was made using the hist command in R. R has an algorithm to choose the bins in a sensible way. It is possible to vary the number of bins and thus also the bin width. However, too few bins will remove some interesting information, whereas too many bins will lead to a chaotic picture. Now, it is clear from the histogram that the observations are concentrated around 2 peaks. Note that this information would have been lost in a box plot. There seem to be 2 kinds of eruptions, short ones lasting between 100 and 150 seconds, and long ones lasting between 200 and 300 seconds. Once this has been noted, it is up to the geologists to explain the mechanisms that might cause this behavior. Another example is this one, a dataset consisting of the length of adolescents and of their biological parents. We will revisit this dataset later on. For now, let's focus on the body length of the mother. We make a histogram of this data. You might recognize the bell shape of a normal distribution. Indeed, when drawing samples from a normal distribution and making a histogram, it looks similar. But maybe this is just a coincidence? Well, let's investigate and look for a method to check for normality. An easy method to compare data to a distribution is by making a QQ plot. On the vertical axis we put the order statistics, from the smallest observation x brackets 1 to the largest x brackets 111. So these are the observations from the dataset. On the horizontal axis we put the theoretical quantiles of the distribution we are dealing with. In our case, let's take the standard normal one. As an example, for I equals 56, we exactly get the quantile Q0.5, which is the median. The median of the standard normal distribution is 0, whereas the median in our dataset is the 56th observation, which is 168. As you know, any normal distribution is just a linear transformation of the standard normal distribution. Hence, if the data were taken from any normal distribution, we expect the points in the QQ plot to lie on a straight line. And this is approximately the case. So using this graphical tool, we may conclude that there seems nothing wrong with the assumption that the data follow a normal distribution. The observations do not exactly follow the line, but this is to be expected. As the points are generated randomly from the normal distribution, there will always be some variation present. For comparison, let's see what the QQ plot for the geyser eruption data looks like. Since the histogram looks nothing like the normal bell curve, we already know that these observations are probably not taken from a normal distribution. Well, the QQ plot clearly does not look like a line. Hence, we can draw the same conclusion. By the way, do you notice the connection between the histogram and the QQ plot? We see a lot of observations between 100 and 150, resulting in quite low slopes. And then there is a gap, with hardly any observations between 150 and 200, giving a very steep part of the QQ plot. And then there is a second group of observations. The box plot, the histogram, the QQ plot, they are all useful tools to get a first idea of the distribution of a variable in your dataset. In the next video, we will see how we can investigate the connection between two variables. See you then!